well. All right, are we live? I think we're live on Twitch here. And we're live on YouTube. All right, are we live? I think we're live on... Don't do that. All right. Here we are. Okay, so I think I'm going to try doing this in CodePen today. Basically, the goal being to publish it into Sudoku tools. But first, oh man, this hurts. First, I'm going to do a quick CodePen version of it. And maybe like a little demo, perhaps one for SVG and one for Canvas. So, and whoa, did I just? Yeah, I must have control scroll wheel. And the algorithm we're talking about is the get cell outline. And this is the algorithm that I'm using for drawing killer cages and the selection boxes in SudokuPad. And basically what the algorithm does is it takes a set of cells on a square grid and an offset from the edge, and it basically generates the path that can be inset, outset, and has all the right pieces. But I think currently what it does is it doesn't generate a polygon, it generates a set of SVG drawing instructions, which is somewhat different from a polygon, right? So what I want to do is I want to extract this one, convert it to a format where it either produces one or the other, and then maybe has a trigger to generate the other one. It's about, let's see, it's about 2 pages, 3 pages long. It's not super long, and it's relatively efficient. But it has a lot of these constants and stuff. So I want to, clean this up a little bit because they're inside of the function, which means I'm hoping JavaScript optimizes that stuff out, but it basically redefines these every time the function gets called. Now, I don't have a performance requirement for this function in this algorithm, but of course, there's no reason to be sloppy about it. So, a couple of things. First, we have to remove the dependency on our internal cell objects here. So there's a couple of things. I think it's literally just looking at the rows and columns, so that should be fairly easy. So let's have a quick test run and see what it actually spits out. I'm gonna use this as a little bit of a scratch pad down here. So we have our SVG renderer, which is I think on framework app.svg renderer, and it is called get cell outline, and I think it is taking an array of cells with row column values, and then the OS is the offset, which I could have named a little bit better. Hey Fryer, how are you doing? Welcome to the stream. Yeah, this has been on my to-do list actually for a long time to open source this one. Because I think it's a neat algorithm, and I had a different one for a while and it had some slight bugs that I wasn't aware of, and this one is, I think, even quite performant. And it's also kind of weird, where it's almost like a bitmap pattern matching thing, where I basically created bitmap patterns for all the different combinations of neighboring cells, and it just matches against those. And I'm sure this could be also greatly optimized. But to be able to optimize it, you gotta first have a clean version of it, right? So let's just pass in two things. I think right now it uses row and col properties on my cell structure. So I'm just going to pass, like manually going to create like a 2-cell thing, and I create a 0.2 offset or something, and see if this actually operates. Yeah, so this returns. So basically what this returns is SVG sort of drawing instructions, right? So it doesn't return a polygon with points, but it says, hey, move to this point, draw a line to this point, draw a line to this point, draw a line to this point, right? And this one, row 1, column 1, so, and row 1, column 2, it would be these two. So let's add a third one to give it a corner. So we have a little bit of inside, outside corners and all this stuff. And I think those are the only two kinds of corners, right? Because, yeah, we can have more than one corner in on a cell, but it's just adding more points. So it's row 2, and we'll do this. And it does that. All right, so basically what I'm gonna do now is I'm gonna pull this one out of my code, stuff it into a code pen, add something to draw it with, probably a canvas for now, and then take it from there. So I think this algorithm is pretty standalone anyway, so I can probably just take the whole thing, stuff it in here. Can I change the editors to be on this side? Yes. Sweet. So maybe I'll arrange things like this. And what we're gonna do is, first we're not gonna mess with this too much. Collapse. So what we're gonna do is we're going to do this. Yeah, I don't remember what I did at first. And it worked well enough, but I think it had some edge cases where it would screw up, and it didn't really become apparent until later. And I wanted something super generic and quick enough, you know. And it's not a completely simple task, but it's also, you know, obviously a solved problem. But the nice thing about this method is it's really fast, and I think I check each cell basically only once. So basically what these patterns are, if I can remember what I call them. So I think this is O is out, I is inner, and then this would be top left, right? So this is, so this basically says, do we have an outer corner in the top left side, right? And this basically says, excuse me, this tells us which cells we're looking for. So if you take this structure and turn it into something like this, right? It basically tells us the current cell needs to be in the cage, the cell to the right needs to be in the cage, the cell to the bottom needs to be in the cage, the left cell cannot be in the cage, the top cell cannot be in the cage, and the corner cells we don't care about. And then it basically applies that bit pattern to where we currently are. And I think these are required for knowing basically as we're following the path, right? So we're entering from the bottom left. So what did we say? So we're saying outer top left, outer top left. So outer top left. So I'm guessing it would be this corner up here. And this is our pattern. So we're entering from the bottom left. Yeah, exactly. So we're entering from the bottom left, which is here. And we're exiting at the top right, which is here. So it tells us we're coming in from here, so we need to offset from the edge here, draw a line to here, make a corner and draw a line to here, and it basically generates 2 line segments for this. And then later on, as we come around, it also generates for this one. So this would be the inner bottom right corner. So it would be this one. And this would look like that. So it says, I don't care about what's to the left or the top. So basically, the same pattern works for this as well as for this. It doesn't care if there's any other cells in this cell or not, because it's just generating this little part down here. So basically, this actually passes twice. Like for this corner, for this corner, for this line, and for this line, right? 4 times, right? It matches 4 patterns. Yeah, I don't know. It's funny. It's like I've never actually come across having to do this before, and I've been doing Gamebot for many years. But I guess for grid-based strategy games, maybe? But even then, it's almost more of a drawing thing. Like, you wouldn't need it for actually dealing with cells and squares and stuff. All right, so the question now is, will this just work from here? If I just execute get cell outline like that, will this work? Console P is not defined. Because it's okay, so it's referring to the prototype somewhere here. Oh, no, that works. That's it. All right. All right. So that's all we really need. So we're gonna do a function main. Actually, we're gonna call this init. Right. And then here we're gonna create a canvas. Yeah, I don't know. I was thinking about it so long, and eventually this kind of came out, and I think it's single pass. Well, it's passing over the cells once. So basically what it does, it matches against these patterns, which output a list of segments. And follow shape, let's see, follow shape. And then it basically stitches those segments together into a path. So we once pass over the segments, over the cells, right? And then a second time we pass over the generated segments, right? So let's see, console. And we'll do a here. We'll do that in there. Yeah, I think this does not listen to the console clear command. Unless... does it just? Yeah, I think this console does not clear. That sucks. All right. What shall we call this algorithm? Cell outline draw. Maybe I can do that. So interestingly, this shape doesn't generate a list of segments, which is weird. Where do the shapes come from? Wait. Okay. So we get shapes. All right, well, let's pass in something more complex. Maybe like a T. Or maybe something like this, right? So I don't know what these things are called. So this would be row 2, column 1. Actually, let's do them by row. So row 1, column 3. Then row 2, column 1, 2, and 3. We'll just do them row by row. And then row, these shouldn't have to be in any particular order. No. Column 2, row 3. And I don't think it actually cares if they're 0 or 1 base. It just outputs the resulting polygons accordingly. Okay. What if I stick this on the right, and then I'll stick the... Oh, I can't put it on the top. Ah, that sucks. All right, for now we don't need this anyways. So we get... Yeah, now we have 8 segments, and I probably need to output them something like this, because I think I'm popping from them as I work through them. So this should create a shallow clone. All right. So the segments are basically what we matched here. Let's have a closer look actually. So what's the first thing we're doing is we're creating a grid. So the grid is just a minimal grid of the cells that gets passed in. And I don't think the grid gets... Ooh, I press Control S. Oh, bad thing. Should have done that. So I didn't delete everything. No, okay. So the grid... Yeah. So the grid is just a sparse area of the cells that we're passing in, just arranged in a two-dimensional array. So then... These are our segments, right? So we're matching the patterns on... Yeah, so we're looping through the cells. So we're executing the check patterns only once per cell. But I think it can... Yeah, it checks all the patterns against the cell. So it can have more than one result, right? So let's actually... Yeah, in fact, match patterns is a multi-result, right? Console.log. So let's output the cell and what patterns we're matching. So we can see, okay, this cell has, you know... Yeah, in fact, now that I'm rereading your comment, mine is basically the same thing, like two passes. Once first we create segments, and then second pass we create the actual outline, right? So, as you can see, for example, these cells only match one pattern, so this one will match out pattern, which I believe is... Let's just split this one down. Yeah, so this one would match something like this part as a sort of an upper U shape. In fact, it's not out, it's outer U top. Right, so that's one of the patterns that I'm matching. We have those U shapes, and that's basically one pattern matched, done, right? And it says we're entering from bottom left and exiting from bottom right. And that lets us determine, you know, we have, yeah, in fact, we have the 4 different U's here. Top, right, bottom, left, etc. Solo, I believe, is just a singular cell, right? Which can be part of a multicellular structure, right? So, you know, I can have this as a selection, for example, then this would be marked as a solo. All right, so then the second one, row 2, column 2. Row 2, column 2. I believe this would be the central cell here. Yeah, that would be the left U, outer U left, exactly. And then this one matches 3 patterns, right? And I'm gonna put this somewhere else so we can look at it side by side. Ooh, come on. How do you match the patterns? I'm sure I could optimize it because right now it's literally strings, so I should probably change that to being some sort of data structure, like a bit pattern or something. So this triple match is this one, so I'm guessing it's matching a straight top, yeah, edge top, ET, right? And then we have an inner edge, bottom left and bottom right, IBR and IBL. So it matches these 3 patterns, right? And so on and so forth. Now, what it does in the end, it's generating sort of drawing instructions. Okay, so that's our match patterns. So the match patterns are basically flattened into the segments. So basically, you know, we went from 4 cells to, you know, 1, 2, 3, 4, 5, 6, 7, 8 matches, right? So these 8 matches translate into 8 segments, and these 8 segments do translate into 8 shapes. I think that's actually a one-to-one mapping. So shape to points does that, I believe. The nice thing is each individual function here is actually quite simple. So shape to points, it's literally just this one loop because the way I've matched things up, right? So, so for example, point OS just adds the offset. So this one is basically generating points, right, shape to points. Whoops. Yeah, and then it basically just figures out if it's a move or a draw instruction, and then at the end adds a Z, right? Yeah, in fact, it says, hey, you know, if the first one gets the M for the movement, and then this one basically turns into an SVG drawing instruction quite easily. I think because these are all absolute, you know, capital L, M, so these are not relative movement instructions, the polygon for this is more or less these points anyways. So it's actually, the algorithm is not too different. To be honest, the M and L, I could probably pull out of there. I just needed it for SVG drawing, and then from this, it was very easy to actually turn it into something. So let's have a look where this is actually getting used. Yeah, so for example, these edge points then map very quickly into an SVG path. And of course, the coordinate system here is basically 1 unit per cell, which then needs to be translated to the actual internal units of the SVG. All right, so step 1 is create some sort of sample drawing thingamajig, right? So we're gonna do something like let canvas equals, so we're gonna create a canvas. Right, and we're just gonna make it some sort of arbitrary size, I don't know, 400 by 400 or something. So something like this. And then, the context, and we'll do, yep, append it to the body. Right? And we should have a canvas here. And let's just test it out. Just make sure we're actually ready to draw. Yeah, well. All right. Generic estimator for segments can join other segments, so pattern matching is a bit awkwardly split across the passes. Ah. Yeah, I think to be honest, I went overboard with the information. I think some of it can be derived, like the enter and exit. I think a lot of this was done to make the other steps much easier. Where am I using these? It's annoying that I can't... One second, let me just put this over here because I'm used to the syntax highlighting from Sublime. Yeah, much better. So, for example, flip direction. Is that even used? Flip direction, exit side. Exit direction. Yeah, so we have the exit and enter codes, basically. You know, the left side is bottom left. So the side is sort of on the left, but it enters from the bottom. So, you know, the first letter is the direction from where do we enter. The second is on which part of the cell do we enter, right? And why does it use flip direction next enter? Ah, yes, of course. So if we're exit direction. Yeah, exactly. Basically, flip direction translates exit directions to enter directions, and so on and so forth, right? And then get segment. I mean, each of these functions is super tiny, but maybe we can actually minify these even further. Yeah, so for me, I think that metadata is basically the enter and exit routes. right? And the points basically describe the polygon. Did I end up using those? I think, yes. So for example, the corners only have, wait a second, corners. The U-shapes have 2 corners. Yeah, so these are the corners, right? So a U-shape has 2 points. So as we're going around that U, there's 1 point here and 1 point there, right? But I'm gonna render it first, because then it'll let us look at it. And I think I'm gonna do SVG and CTX in parallel, side by side. And to generate an SVG element, we're gonna steal some code from render part, because we need this. I might want to go full screen on this soon. Otherwise, I'm getting too many boxes here. So, document.body.append child SVG. Now, I'm not entirely certain how much stuff I need to add for an SVG to be a valid element. I think I might have to add a bunch of things. Yeah. Create JavaScript SVG element. I think you need to add the namespace and a bunch of extra things. Yeah, like this sort of stuff. You're still using create element. Okay. So, don't know if I can use object assign for this stuff. Let's see. So let's output this SVG dot. If I just assign this directly without using attributes, will this work? I'm not sure. Okay. Get attribute. Like, is this different? So that's null. If I do a set attribute, I might have to put them in one by one. That'll be annoying. I was hoping to use object assign, that's all. So get attribute works when I use get attribute. Does this property work if I use get attribute? No. Okay, so you gotta use get attribute. Alright, alright, alright. I'll do it your way. Fine. So, version I don't think I need. Width, we'll do it the same width. Let's make these 400 as well, so we kind of know. Okay. The width and height here are not translating. Even though it says width height 400. That's curious. I would have thought that would force it to that size. Width 400 pixels, height 400 pixels. Alright. Now this one, I think I can assign. No, CSS text I would have to assign. Yeah, I think so. But we can do the same thing with our canvas object here. Load left. All right. All right, that's our init. And then we'll shift over to main just to get rid of this spam here. We'll do canvas CG. Size. All right. We're gonna need some kind of SVG element creation thingamajig helper function. This one we want to unindent, if possible. We're missing a bracket here. All right, so these are our two drawing surfaces. I think we're gonna do, let's create SVG, create, something like this. Don't know why I switched to part when Elm was a perfectly fine word. Okay. And then we'll just, attributes and all that. So object.entries attribute for each. And it's passing in an array that consists of a key and a value. And we're gonna do element.set attribute key val turn val. So we should be able to do something like g create elem. We need a type group type. So let's say a rect, and we want it to be at width 100% or 400 units, height 400, and fill blue. Just to test that this is working, and we can draw stuff. Type attributes, key val for each object entries at 96. I guess it was brackets around this array. There we go. Except I think we need to also add it to it, right? So we'll do svg.end child nope. Nope. It doesn't like that. Let's see. Wait a second. We're not hitting any of this stuff because we're not calling it. That's why. Namespace URI. Properties of undefined namespace URI. Am I looking at the wrong thing here? SVG is undefined. Probably because I have a let here. Yeah. Okay. We have a rectangle. I mean, the console we have a rectangle. It is here. Width and height is not... Doesn't like our width and height values here. Do I have to give it units? I don't think I had to. In the past I've used percentages. Maybe it does need units. Which is kind of ironic to use pixel units. Nope. Nope. That's another big nope. Is it width and height? Pretty sure it's width and height. Width, height. Yeah, and it can be a number. Doesn't need to be a string. There's some silly detail that I'm missing. Rectangle, width 100, height 100, fill, blue. There's something slightly off. And I can't put my finger on it just now. I need something with a background color that I can actually poke at. So, rect, x, y, width, height, fill, stroke opacity, opacity. Does it need an x and a y for the width to kick in? Magenta, my go-to debugging color. No. What am I getting wrong here? I mean, it's assigning the attributes. Is this maybe a problem in here? The namespace, width and height, do those need units? I mean, it has the right size already. Let's have a look. Namespace. I mean, we have a view box. Maybe we need to assign a view box. This doesn't. It does have, but only in. XML and S. Is this the right namespace? XML and S. HTTP v3 org 2000 SVG. 2000 SVG version 100. Rectangle. Rect. Fill. Stroke width. X, Y, width, height. X, height, Y, width, height. There's something not quite right. I am assigning attributes here. It is rect, right? That's correct. I'm trying to remember. There was some weird quirk of SVG element assignment. That's why I have to use that create element NS. But the namespace is assigned correctly as far as I know. Maybe it's not append style. Maybe it's not append child. Maybe it's append something else. SVG query select append child. No, it looks like it's just append child. Ah, wait, I think I need to do this as well. Or the SVG element itself. That's what I've been getting wrong here. Ah, there it is. I'm already seeing it now. And in fact, I'm tempted to pass in the parent here. Yeah, it doesn't matter. All right. At least now we're there. Now we can draw things. Yeah, it was the namespace. For SVG stuff, you have to use create element namespace. I don't know why. Thank you, W3C. Okay, so step one would be actually to create a path. We're just gonna do something like this. And we're just gonna do this, outline data. Okay, see this, where did I do the thing? Where did I do the bad thing? Here. Okay, and I should be able to convert this to, you're gonna map if I do this, I think that's everything we need, right? If I add enough brackets in the right places. Like here. So if I do path.set attribute this, yeah. Now obviously we need to scale these, right? Because they're in units, unless we make this bigger. But for now, I think we're just gonna scale them here. So what we're gonna get here, we get the pen, which kind of pen? We get the X and Y. So this is going to be pen X times 100, yeah, times 50, and Y times 50. And stroke width of, I don't know, 3. Then is not defined. So I made it a P over here. Ah, there we go. Look at that. All right. And now we can mess around with the offset to, to show what the offset does basically, right? And offset 0 would basically just outline the cells. Kind of like that. And an offset of negative, let's say 0.3 would bring the outline outside of the cells, right? Now I want to see if I can draw the same sort of structure onto our canvas here as well. So let's see if I can do something like this. Basically do this, right? And then we should basically just translate those pen instructions. So switch E, and here it's really just 2 cases. case m ctx dot move to xy break, and L is just, I guess it has basically the same interface as SVGs in some sense. And we probably need then to do ctx.begin path. Oops. ctx.fill. Check. I don't know. And stroke. And here we have the same kind of multipliers. We'll probably want to do like a little helper function. So we can do something like pxy becomes px times scale y scale. Or do something like this, path scalar, we'll do scale, and that returns a function with something like point, or basically this. I think. Why did the music stop? Because my settings have been forgotten already since I rebooted. That's all it took. If I do this here, scalar 50, then I wouldn't have to do this afterwards. Mm-mm-mm. 93. 93. Oh, it still wants brackets here. Braces, sorry. Braces. Brace thyself. Alright. We can do the same thing here. And we don't need to do this. Alright, it's still not outputting this. Expected path command, yada yada yada. Path scalar. I guess my path scalar isn't doing the thing it's supposed to do. It looks like it. Because Z doesn't have an X and Y, basically. How do we do that? Don't tell me I have to kind of be smart about this now. Seriously? What if we just do this? All right, and then item.map. What's a subpart of an item? Segment. I guess this is a segment. It's not a segment. It's an instruction. It's a drawing instruction, right? I don't know what you call these, actually. What do you call that? I mean, it's an instruction, I suppose. Let's call them parts. So part, map, the property, right? For each property, type of prop equals number, return prop times scale, else prop. Does that work better? So it should now not add to that z. That should work now. Good. And I'm scrolling the wrong place again. Operation, yeah, I suppose so. Yeah, maybe that's better. Oh. I hate naming things. So, ctx.fill. Failed to execute. The provided value is not valid. ctx. Fill style equals dot stroke style equals, that's my problem, ctx dot fill dot stroke. Is that better? Hey, there we go. There we go. And if I do this the same colors in the SVG, which I believe was F0, F, what do we get? And stroke width equals 3. This looks almost like a glowing effect, but probably it's an interaction with the red in the background. Stroke width, stroke style, canvas, stroke width, stroke size, stroke style, stroke, 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 stroke style. Stroke, line width. There we go. Now this one doesn't get closed automatically. So canvas, close path. I think if I do end path, close path, all right. All right, at least this is a proof of concept that the SVG and the canvas output are similar. All right, so this algorithm already works pretty well. Probably a few things I want to change is the row columns should just be arrays, right? So instead of .row.col, it should be just 0, 1 in an array. Should I still call them cells? I guess so. Even though I'm not actually passing cell objects in anymore. Let me get rid of this. So let's see where we're using cells. And once again, if I double click over here, it gives me a nice little highlight. So down here, cell. So let's simplify that first. Here. Wait. Why does this give us the cell again? The thing is, that like lets us get rid of the grid basically, doesn't it? Because what are we going to store in the grid? I think the grid is basically becomes just a true false, right? So this becomes a true here. And then cells for each cell. This shouldn't be happening anymore. Because we're not Wait a second, outline data. We run this to the path through the path scaler. Oh, because of this. Okay. Yeah, we can go back to the simpler version now. I think. Okay. Okay. So now we got rid of, well, we didn't change anything actually. So we can change these, we should be able to change these cells now to be based on arrays. I mean, to be honest, if I just do this, that'll already do the trick, basically. Then I can just do this. Nope. Don't know what Dropbox wanted. I don't care. Go away. Leave me alone. Okay. And a pow. All right. So that whole row column shenanigan stuff is no longer needed here. Now it's pushing the cell in here, but I don't think we actually need that. Right? Let's see. So where we're pushing these to segs, and then segs length follow shape. Follow shape does this. Segs 0. Get segment segs. Yeah, so we're explicitly basically ignoring that cell reference anyways. Cell here isn't used. Let's get rid of that. It's not used here either. Let's get rid of that. So, I'm doing it in the wrong window. That is a risk. So that's the pattern, and there was another place. Nope. I don't know since when it started scroll wheeling to change tabs. It's so annoying. All right, there was another reference to cell in that array. Yeah. 6 RC enter, 6 find RC pat. Get next 45. Segs find RC pattern. R RC pattern. Follow shape. There we go. That should do it. I'm just going to remove anything that's actually not really strictly required. Okay. And then we kind of just simplify out any extra bits. Because basically this grid is just a, like if I look at grid now, it's just a true false for the cells. And I think the only place I'm using that is for the neighborhood check. So if we look at grid. Yeah, it's used in the... It's like an index. I'm trying to think, is there a better way of doing it? I mean, I could just search through the cells array, right? But it feels inefficient considering it could be fairly large. And I guess just it being undefined. I mean, now it's true or undefined, so I think we can simplify this a bit. If grid R and grid RC So that makes sure that we don't check outside of the grid. Or false. I don't know why or false is required. Oh, I think because this might return undefined otherwise, right? Yeah, so this converts it to a Boolean basically. All right, so far so good. This I think we can get rid of. So I can just do this here. Oops. I want to get rid of as many references to cell as possible and just dumb them down to being RC pairs. Check patterns, match patterns. We don't actually use these for anything else. So we can just do this. We don't need that anymore. And we can do that. Oops. Like that. Also, I don't know why I did that here and then ran it there. Now this is all screwy. Uh-oh. They're screwed up. Okay. I think it's still working. All right. Right now I'm just doing some basic code transformations just to simplify it, make sure I don't have anything in here that we don't actually need. Points. For example, can we replace this with a filter? Shape to points. Shape split pattern points. Because some of them have more than one point. Okay, fair enough. Grow, column. I mean, this is ensuring that each row exists here. I guess we could do this. Right, and then we can get rid of that. Yeah, that works. While segments of the shape. So we're popping segments. Follow shape. I'm wondering if that's also a place where we can simplify things. Yeah, that's one of the more complex functions here, actually. Let's see. Shape is an array, segments. We start with the first segment. So we're pushing the first segment into the shape. Then we're removing the first segment from the shape. That seems a bit awkward. Why don't we just pop it? Or unshift it or whatever. And then seg equals get next segment. But it could be that the next segment is not, like, it's not in order necessarily. So let me think. The shapes are... No, let me think. The segments are our bits here. And let me get rid of all the SVG and canvas malarkey here. Don't need that. Don't need that. Anything else we don't need? Keep the console clean. Okay. So the segments are the individual bits we've pattern matched. Right. So we say, okay, we've got at this R and C value, we have that thing. All right. So then for each segment, we're following the shape. So that we're getting them in order. Okay. So this is basically ordering them. And we're starting at whatever the first segment is. Okay, so we're starting at the first segment, whatever it is, and then we're following its exit and entries to get the shapes into order. That algorithm might be inefficient. I don't know if there's a better way of... And that's why it's doing this, instead of just pushing and popping, because we're not actually going in order, right? So we start with the first one. But get next might be whatever, right? And the reason it's recursive... it's not recursive, it's just calling get segment, all right. And here it basically says, okay, find me a segment that matches a specific pattern. So we were saying, okay, we've just, at this particular position in the segments, or they're just all the segments, right? The next row column value is this. So we find one where this is the RC, and we're entering at that position. And that's what this find does. So this could be the performance issue-ish. I mean, the whole algorithm is not a huge problem. But basically, we have to search through all the segments. So if we could index the segments somehow, and in this case, if we could index them by the grid position, so so I'm thinking we could store the segments here in the grid structure, because right now the grid is just true false, right? But what if each grid position then gets a list of segments in that grid position, and then we don't need to search through all the segments, we only need to search through all the segments within that particular grid position, which would be a lot easier. Yeah, I guess, but then you have to have another pass to generate that map first, right? That's basically what I'm just contemplating. I mean, if I kind of compromise and index it by the cell, which I already have an index for, so instead of marking this as true, I could just make this an empty array, which is not undefined. I don't know if it'll still work. Yeah, it'll still work. So now I could say, okay, as we're creating segments, right? So here we're adding the segments to the segments list, right? So we can say new segment, and that's what we're pushing. So just instead of just pushing it onto an array, I mean, we still need an array because we need to kind of be able to iterate through them and kind of remove them when we're done with them. Or at least mark them. So new segment 8 times. Oh, there we go. By the way, Fryer, are you dent up from Discord? All right, so these are the segments we're pushing. So we have a row column, and it just, So instead of pushing row column here, so patterns, all right, let's just shorten that pats, right? What if we do grid row call dot pats dot push at, and then we can put the grid out again. Undefined reading push pats. So grid should have pats. But we shouldn't have pats. We shouldn't be trying to assign them to empty ones anyways. Wait. What am I doing? This is a JavaScript. All right, so now in this grid, we have all the patterns in each individual cell. The thing is, I think we still need the linear list, right? Because we're removing the segs. And that's, yes, and then as each segment gets removed, this find algorithm... But we could also just as easily remove them from these patterns, right? We'll just have to keep a count of where they are. Well, then we'd have to loop through the grid. Okay, it makes sense to have a linear list of these as well. But this get segment algorithm here, maybe we can simplify that one. So, So let's just see what's happening here. So for example, get segment, we're looping through all of them. Yeah, I can't open them because... no, because that's segs, all right, because that ends up empty. And we want the segment at this RC and this TR, okay. So next RC is this. Next enters this. So now we basically could take RC and just look for that in the grid. So we could do something like, we'll just do length, because that's the only thing we care about here anyways. Could do grid, next RC 0 and 1 dot paths. And then technically we'd have to search through those, right? And then we'll dot find. And what are we looking for? Next enter. Enter. Enter equals next enter. And that should only search through, a much smaller list of patterns. Well, what object? The sex list is the object, basically, right? It's a list of segments we found. I'm just trying to see if there's a more efficient way of, instead of iterating through them linearly, because I then need to match them up, right? Like, as I'm going from one segment to the next, I need to find what the next segment is from its entry and exit positions and so on, right? Because the list is not necessarily in order. I mean, I could make a presumption about the order, because as I'm adding... Yeah, no, I can't, because like inner and outer edges are discontinued on the path, disconnected on the path, right? All right, so... this should now be identical to the result of getSeg. Right, so if I do this here, we should get the same segment twice. Except here we're only iterating usually one or less elements, while here we're iterating all of them. So many more. Undefined. Why did we get undefined here and not here? Yeah, because that also returns, obviously, yeah. Okay. Because I'm not removing them from there. All right. So we could get rid of the getSex call and replace it with this, but it also means we have to remove them from our thingamajig. So let's see, console.log, remove seg. And the segment itself has RNC. Well, let me finish simplifying this, and then we can always compare notes afterwards. I wouldn't be surprised if it kind of simplifies down to the same basic algorithm. The nice thing about this one is it's quite battle hardened, because it's been used for the selection for more than a year now, I think, since I've put this in. Let me see, actually. This version, after the sort of refactor, when that happened. It happened a year ago. That's not very accurate, is it? 11 months. Okay, so maybe around 11 months. With like 1 million users or so. All right. We're removing this segment. So we're going to do grid seg 0 seg 1 dot paths dot index of seg So we still have to do index offs here, which is still linearly searching through the array. But at least these arrays are really short. I mean, I'm trying to think, if I invert these, what could I index them on? What's the information here? The name, I guess? I guess the name would be a unique index. Yeah, because that's really the only thing that matters, right? All the other stuff... I mean, I'm just storing references here, but this string is uniquely identifies that, and there can only be one of these, so it could really be a bitmap on those. And then we just, you know, it's just true, false on these elements. So that inversion would get rid of all these linear loops. All right, let's reduce them first, and then maybe we can eliminate them altogether. Remove seg -1. Okay. I hate this stupid indenting. Why does it think I want to indent to the frickin' bracket? Who does that? Who indents halfway down the line to align with a stupid bracket? That doesn't make any sense. All right. No get index off here. So remove segment. So we're removing ET from this list, but it comes back as a -1. That doesn't make any sense. All right, let's try. I mean, if I'm gonna do the work, let's just do it all the way, right? So instead of these patterns being an array, this whole thing is just gonna be an object, right? Instead of doing this, we're just gonna do this. Name equals true. So if we do this, grid, so this will just have true falses for whichever one of these exist. And I mean, we could even turn these into a bitmap, right? There's, well, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, there's 17. If there was only 16, can solo doesn't actually need to exist. Solo could literally be the 4 outer corners, for example, right? Even the U's we could get rid of. The U's are just two times outer corners. Like I thought I could, because then we could turn the whole thing into like an 8-bit bitmap, and then just the whole thing would just kind of, all the code would more or less disappear and turn into bit wrangling, but it could also become completely unreadable. Yeah, this isn't gonna work anymore. Undefined burp burp burp. Yep, this ain't gonna work anymore either. In fact, this isn't gonna work either. Because now instead of a find operation, this becomes a true false operation, right? The only issue then is we need to translate next enter into the different thingies here. And the problem is, in theory, we might have more than one pattern with the same entry. Is that right? Like both of these patterns enter bottom left. So we'd have to check both of them. That's annoying. But I mean, we could do a static index of that as well. So forget the remove segments call right now, because we don't know how to do that yet. We're still in the process of finding the segment here. So get segment, 6 segments. This is the RC. This is the next entry, right bottom. This is what that cell contains, and this is what get segment returns. So it returns IBR. So we now need to match IBR to the RB on that thing magic. All right. So const enter to pat. So for example, top, right, bottom, left. So let's see, top, top left. Ah, this is going to be annoying. This is going to be annoying. Let's make the computer do the work for us, because that's what it's there for. Right. Lock. Enter to pattern. And we basically need to do this. Patterns dot map enter new set map enter dot sort new set back to array. That should be our list of entry points, unique list of entry points. Bottom left, left top, right bottom, right. It's definitely more than what's showing here, unless I'm mistaken. Bottom left, bottom left. So we have bottom left times 1, 2, 3, left top times 4, top right, right bottom, bottom left, left top, top right, right bottom left. There's only 4 plus none. Okay. Oh, I thought bottom left, but there's no bottom right. Bottom left, right bottom. Right bottom is from here. There's no from. How's that possible? Oh, yes, of course, because we're only going around the thing in a clockwise direction. So we never get the entries the other way around. So we don't get the mirrors. Ah, okay, that makes it a lot simpler. So now we're just gonna map these. Enter to patterns dot filter pet dot enter equals enter. So that should turn each entry element into an array of all the patterns that use that entry element. And then if we map those to map names, then that should give us our object, right? Oh, I hate CodePen's indenting rules. Okay. Ah, wait, no. Something like that, I guess. Close enough. We can wrangle it from here, I think. Nope, we're not going to wrangle it from here. We're going to wrangle it from there. That's just... It's easier to add a couple line breaks than to remove all that rubbish. Holy moly. That was a bit much. Okay. So the solo one, does it ever apply? Because if we don't have an entry, we'll never need to look it up here. So this one we don't actually need. Alright, so this lookup table should enable us to get rid of all those array loops. So, back to, was it getSeg? Yes, getSeg. If I do enter to pad, next enter. So we now have these patterns, and then we can do basically this, and that's a singular property lookup. I mean, it's a bit of a nested mess, but so we have next enter here. We have this is what's in there. We're converting that entry, RB. So these patterns have a right bottom entry point, and none of them, and those are not found in our, none of these are found in here, except they are. There's an IBR here, which is true. One second. Enter to pattern. Enter to pattern is an array. Oh yeah, because it's an array, so we need to actually check. Ugh, we still have to check the whole array. God damn it. We still have to check all those options, right? Can I get rid of that? Can I get rid of that? Can I get rid of that? Instead of putting the patterns here, does it make more sense to put the entry point? Let me think. Can more than one pattern... Hey, Elias, how are you doing? Can more than... I think the entry point is also a unique identifier, right? Because all the others are mutually exclusive. You cannot enter a cell and then go... Yeah, no, you can. Obviously, you can. I can go straight across. I can turn up, right? Both of them have the same entry point. And this one doesn't care, it just cares what's the next segment, right? And since this is not a list of segments, it just wants to know any of those, are they true here? So it means we still have to loop through them. Can I avoid this? Not really, right? Not really. There's always more than one option, and then you have to just check all the different options to see what's actually the case. The question now is, are we making things worse than they were before? Because before, we were checking all the things that there are. Now we have to check all the things that could be there. And this list is always 4 items long, while the list of what is there is actually usually much less. So what we really not need is the reverse, right? We need an index of these to the entry points or the patterns themselves. So pattern index, huh? So I do a pattern index, and I can just do this, reduce accumulator. No, I always forget. Is it accumulator current or current reduce accumulator? I always forget. It is previous value, current value. So accumulate the current. Assign accumulator car dot name car right. There we go. That's it. That's all the braces fixed, right? So our pattern index would be this. So we can do const pattern index equals to. Whoops. So now with the pattern index, at least we can now look up the patterns. We can look up the entry points from the patterns. So that means instead of doing this, we go the other way around. We go back to the grid value, which is this one. So that gets us this list. Actually, it gets us this list, right? So we can do object.keys. Unless we literally just assign the patterns straight there instead of true. So if we just do this, then we can save all of that shenanigans here. So that just has a reference to all of the patterns indexed by their entries, by their labels. And now we still need to find, or do we do it the other way around? I mean, we could do a three-dimensional grid structure. Yeah, the thing is, I still need to encoding it as a bit field. I mean, that's what I'm basically doing. But that's just a different way of storing the same data. The question is, can I avoid the looping, right? I guess if I indexed it on top of that by entry, by enter values, and every pattern only ever gets entered from one. Basically, if I do a three-dimensional structure, right? Row, column, and entry point. The thing is, you still have more than one pattern per entry point, so it still doesn't help. We'll get the smallest possible list, right? But and that list, off that list, we literally just want to pick the first one. But it really doesn't help us much. I mean, we're talking reducing a list of 4 checks to 2 or 1 check, and 4 checks only in exceptional circumstances. So I don't think the overhead is just... And we still need this for another check elsewhere. Because we're relying on this grid check somewhere else. Yeah, for the neighbor check, where we don't care... wait a second. For the neighbor check, we only care if there's something in it or not. 1 second. Where are we dealing with the grid? So we're taking the grid, right? And I think the only place, here we are assigning it. And in fact, cells for each grid row call equals. We don't even need this, right? This part we don't even need. We can get rid of this line. Where else are we looking at the grid? Only here? Seriously? Ah, no, up here. So we're just checking if there's something at that cell, basically. Is that really... Is that something we can just skip? Ah, no, we need it for the pattern check. Okay. Well, it doesn't matter what's at that cell, right? Whatever we put there is fine. Should I do it three-dimensionally? Because now I'm thinking a three-dimensional bit field is basically... what's the word used for the binary space partitioning, right? And since our values are relatively small, we could do it in a reasonable number of bits. Okay, first of all, let's get rid of this. Because now we can just do grid, row, or blah, yada, yada. Grid column equals grid row call equals itself or wait, itself, which we've already if and then what's the next one? The next level is if row call pet.enter equals undefined equals, now we're back to an array. No, we're back to this. And then enter pet.name equals pet. Right? Why is it so small suddenly? Okay. Oh no, I'm an idiot. No, I copied everything over before. Maybe I did. Maybe I just started editing on the left, and then I copied it back, and I don't have any of the code that I've been working on the right in the meantime. This is not a good way of working, but here we are. Here we are. This immediately dies here. Why? Oh. Oh, because we need this before check patterns already? Wait a second. Does check patterns... we need the grid already set up by then. Alright, I can't skip this then. Yeah, no, I can't skip it. Okay. Wait a second. Okay, that means by that point we're already done with the use of the grid data structure, basically. By the time we get to this, we're already done with it. So that means, alright, well, this is all unnecessary. So now these structures are three-dimensional because for each entry point, they have an object indicating which elements for that entry point are available. The annoying thing here is now, as I'm removing them, I have to do multiple checks, right? Like if it's empty now, I have to remove the whole thing. I cannot, otherwise I'll do object keys.length or whatever, which I'm certain is not going to be faster or anything like that. The other option is to flatten this structure and combine, make the key a combination of the entry point and the element. Because each of them have one specific entry point, right? But then we're losing the ability to just check, hey, do we have something with that entry point in here? I mean, that's the thing. This is a two-dimensional check, so we can't just skip one of those dimensions. When we flatten it, then we're just checking more stuff, right? And to be honest, that's the ultimate thing. Previously, we were just checking everything, right? It was completely flat. So let me just get rid of this for a sec here. So we have 7 segments. The exit is TR, right? On the cell, we have these, but we only care about the ones under next enter. So if this is undefined, then we already know, okay, we're done. All right, so these are all having something, and they should, right? Because we're going around a loop, right? To be honest, if we don't find something here, the whole thing blows up, right? We don't have a closed shape. Now, in this case, there's exactly one each, which wouldn't necessarily be the case if we have a hole in it, right? So if we go something like, what was the shape we were testing with? So if that's our shape, we can't exactly put a hole in it. But if we made it bigger and do something like that, or vice versa. Yeah, to be honest, the solo thing we should get rid of. Oh, cramp. Why am I gonna cramp? Ow, ow, that hurts. Oh, I don't know what to put my legs, and my leg just said, no more. Because I have the U shapes, right? And I think I can just do away with them. Maybe that'll be a more interesting exercise, actually. Simplify the number of patterns we're actually using. Because I think it was a way of speeding no, because I'm passing through the cell only once. I'm not going from corner to corner. If I subdivided the cell into 4 quadrants, then I would really only have to deal with inner and outer corners. And if I do that might be another way of looking at it, right? If I subdivide the grid into quarters, then I only have inner and outer corners times 4. And if I can apply rotational symmetry, then my checks basically become 2 checks. And I can get rid of all these other patterns. So I think right now what happens is that I'm... and that sounds actually like a much better way of doing it, huh? Because right now I have all these all possible patterns for a full cell. The question then becomes, if I look at the corners only, I mean, similar things still apply, except now it also applies to the quadrants within the cell. Can I... Okay, the question is now, can I simplify the code by first subdividing the grid and then making certain assumptions about the corners? Because now I know... so, okay, it's hard to imagine, explain what I'm saying. If I double the grid's resolution like this, right? Now I know that whenever there's one of these 4 part of the element, all 4 are, right? So I never have this event anymore because I've doubled the resolution of the grid, right? And now I only have, you know, outer corners or inner corners in any particular cell. Each cell only ever has 1 corner in it. no matter if it's a U, if it's a singular cell, right? So by doubling the grid resolution, I now know there is no duplicate, like the line doesn't pass through any particular cell more than once. And can I use this to my advantage then, basically? That's the question. Because, so for example, let's say, let's draw this in, right? This cell now can never, you can never have a neighbor left and no neighbor left and no neighbor right. And I guess it depends on where in our subgrid we are. So if we're on the left, or like the top left, then we only need to look at the top and the left neighbors. On the top right, we only look at the top and the right neighbors, basically. And I'm just thinking, is a way of abstracting this away so I don't actually have to do this work first and just look at them that way, right? And then just kind of parse the corners out individually. Because this was fairly complex to figure out. The nice thing was that they all work exactly the same, so I had to figure it out only once, then just enumerate all the possibilities, right? But now I'm wondering is, can I get rid of that as well? So my pattern check right now is dumb because it just looks, it's a pattern check, right? It loops through the pattern. But that's relatively expensive if my actual patterns are much simpler. Because my actual patterns are really just, do we have one neighbor, two neighbors, or no neighbors? That's basically the conditions. So this cell has no neighbors. This cell has two neighbors, and this cell has one neighbor. So if it's a one neighbor, it's straight. If it has two neighbors, it's an inner corner. If it has no neighbors, it's an outer corner. And no neighbors, outer corner, right? One neighbor, straight line, relative to where the neighbors are. So it's like literally just 0, 1, or 2. So 3 cases. Okay, so now my brain is saying, hey, what if... what if we look at a singular cell... Sorry, with that cramp I got kind of discombobulated. If we look at a singular cell, let's say this is our cell, right? And we're just going to look at the 4 corners that are our potential points, right? Because this is super generic. And in fact, it's actually overcomplicated because the U-shape have 2 points, right? Which makes... And the solo has 4 points, which makes turning this into a polygon a little bit more complex. I mean, I've done it with not a lot of code. But if we look at it this way, and basically for each cell, we actually make 4 checks, 1 for each corner. And then the checks themselves become super simple, and we don't have to do the pattern matching anymore. So each check... And in fact, do we care about corners, inner or outer corners? We somewhat do, because of the offset. But mostly, we want to, because we need to know if this point goes here, here, or here, right? And it depends, it moves inwards or outwards according to if it's a corner or not. Like if it's straight, it should just move straight down, right? Unless we don't mind having 2 points at the transition from, basically I wanted to avoid, how do I explain this better? If this is our cell, for example, right? Then if this is a straight edge, i.e. there's cells here and here, then I want to move this point only to here, for example, or to here, depending on the offset. If it's a corner, I want to move it inwards, right? Outer or inner corner. So the point, the polygon goes from here straight across. Let's say if this is an inner corner, yes, it looks like this, right? If it's an outer corner, it'll look like this. If it's a straight line, it'll look like that. And our endpoints are here and here. but I think that could be done elsewhere. I mean, I didn't really plan on changing the algorithm because I'm quite happy with how well it works. But there's a lot of shenanigans going on with strings and strings turning to arrays, and, you know, I'm checking versus strings, and it should be a bit field, you know, and all this sort of stuff, and I was a bit lazy. But at the same time, this is much easier to understand than if we turn it into an actual thing. Also here, it's modulus 3 row, check RC, row column, it's, oh, because this is 3 by 3. I was wondering, for a second I was scared that I made it specific to a 9 by 9. No, but here, yeah, I'm splitting this into a, anyway. So if we just hard code 4 checks, it's a little bit more code, because we're kind of replicating the code, right? But the checks should be really fast. So let's have a poke at that. I mean, I'm a bit worried about doing like something different in the middle of doing this. But let's just have a look at this just for a moment. So I'm gonna do this before I do anything else, and then I'm gonna return so I don't have a lot of log spam. Right? And at this point, we basically still want the grid checks. So we're gonna move the grid building here. And then this we can return an empty array like that. Do and we're just gonna change this to RNC. Log RC. Okay, so these are the cells. And if we do only a corner check at a time, so let's say top left, right? So then the only thing we care about, and you know, might as well put that here, is what happens above and to the left, because for everything else, we know they're both true because we are inside the cell, right? So from the top left corner, we're always going across to the other end of the cell. Anyway, you know what I mean. So we can now look at grid. Let's say, so let's do the left check first. Let's do left, grid, row, column, and we need to column -1. That's to the left. And that's row -1. All right, so left above, true, false, true, true, false, true. And that tells us if we have an incoming or outgoing corner. Ah, 1 second. But does this depend on what's happening on the right side of the cell at this point? Only if we care about the direction of the line, right? So if in the moment we're just care if there's a point here, then no. So what did we say before? If both are false, So if I say, okay, left is this, right? And then right is the other one. Not right. Let's shorten this. And before we said, if we have both neighbors, it's an inner corner. If we have one neighbor, doesn't matter which one, it's a straight line. It's just the direction of the straight line might change, right? And if we have... No, sorry, if we have both neighbors... no, it depends on the corner. If we have a neighbor over here, if we have three neighbors... so the three neighbor case is that there's no point. That's the only time when we have no point here. Okay, so we need to check that position as well. So, left up is grid minus R minus 1 and grid R minus 1 and C minus 1. Well, this one we don't actually need to do the grid R check because we're looking for a cell in this row anyways. And we don't, at this point, we don't actually care. Well, we could determine if it's an inner or outer corner. Left up, left up. Left has already been cleared at 89. But this is left up. Unexpected token. True, false, false, true, true, false. Okay, so if we have all three, you know, so if left and up and left up, control worn, no corner. If we have left and up and not left up, then we have inner corner. If we have left and not up and not left up, except I remember this. So if it's these two, if these two are filled, then from our perspective, it's a straight line. So we don't care because the corner up happens in this cell, even if the offset is negative, right? This point is responsible for this. So we don't care for the straights. Okay. So if we have a cell to the left and nothing up, then we're coming straight across. Cell to the left, upper edge. And when we have not left and up, then we have left edge. So we have no cell here, but we have a cell at the top. Like this. Then we have an edge going down this way. As far as this point is concerned, it might turn in the next corner. So this would be basically be our cases for this one edge, for this one corner. And we're gonna have to repeat this 4 times for all 4 corners. Upper edge, inner corner. And now, so we'd have to now repeat this whole thing for top right. So we kind of, these checks would be kind of all over the place, right? So instead of left, this would be right. Instead of this RC, it would be +1. Up. Top. This is direction, this is location, right? Top and bottom, up and down. So up is the same. So these checks, we can kind of group them at the top. So because I'm keen on making this check here kind of thing. So we can do something like let top left, top right. And then we can shorten them and we're back to basically what I did earlier, right? T, TR, L, R, B, L, B, B, R. And then these should all be initialized to false. I think I can do this by doing this. I don't think that's how let works. Right, and then we can do these checks once. If grid row -1, then we do the top checks. So top left equals basically this, but without this check. I mean, they're bit checks. They shouldn't take a long time. Yeah, I don't know. I should be looking at this right now, but I can't help myself. Idea pops in my head. I need to look at it. Ah, in fact, this is row-wise, right? Row. So that's all above. Yeah, so that would be C, and then top right would be C +1. And I can just do this maybe. I don't know why that didn't occur to me before. Because I just want to get rid of the more complex ones, like the U's and the solo and all these weird ones. I can do this. And this. $97. Yeah, none of these error messages really apply. R was already declared. There's no... Oh, row column. Okay, row. Well, whatever. No, I want to keep those short. So top, center, right center, left center, bottom center. Keep these 2 letters. Top center. Center, 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 center. All right, so this gives us a bit pattern basically for each cell of the surrounding thingamajigs, right? All right, let's do this again. So now we want to look at left center, left center, left center, left center, top center, top center, top center, top center, top left, top left, left, top left, left center. Okay. So this only gives us one left edge. That doesn't make any sense. that does not... Oh, yeah, because I haven't done the other ones yet. Okay. Then if grid plus 1, then this is all the bottom stuff. Bottom, bottom, bottom. Grid plus 1, grid plus 1, and grid plus 1. And then the center stuff is... And I think top... So left center, we don't have a center, and then right center. We're skipping the center. That we know is true. So, and these are just that and that. All right, so the first part is, it gives us for the 2-2 cell, so remind ourselves the structure we're looking at is, I think, is this. So, so the 2-2 upper edge, guessing this is this one. And this one, yeah, this would have been the left corner. We just haven't implemented yet. So, top right. And now for the top right one, we look at the 3 we look at are right center instead of the left centers, top center, and then top right. And I think other than that, so no corner if all 3 are filled. If everything but the upper right corner is filled, then we have an inner corner. If the top center is not filled, but the right center is filled, we have a right edge. If left center is filled, right center is filled. No, we have a top edge. Yeah, let's rename these. Top edge. And then this would be a right edge. Yeah, I think one of the issues I had when I first built it was that it's not enough to know which points are assigned. We need to connect the points as well, so we need to order them. And that's basically what the segments do. By using the entrance and exit values, it lets me sort them. Now here, in a way, the sorting is sort of implicit, because if I don't have a corner, then I can ignore it, then nothing happens. If I have an inner corner, I need to look for the next element to the right, let's say. Or whichever direction it goes, right? Like, I care only in which direction we're exiting, and then just keep following around. Touching things under the pile of cables under my foot are making me nervous. So, for example, for the top edge, we just know we came from the left and we're going to the right. So in the next cell, that's the thing. In the next cell, we need to look at the top left point, for example, in the next cell to the right. So I'm wondering if it actually makes sense to think about it differently. Instead of looking at all the points on a cell, is we start at a cell, we look at one point only, and then we just start following it around. Yeah, okay, no, this doesn't work, right? Because it could end up with islands, and we could miss out, you know. So, you know, if I have something, let's say, if I have a bunch of cells like this, and then this is missing, I start here and I just follow the points and I miss this altogether, right? So that's why originally I first generated all the possible elements, and then I pieced them together into a coherent polygon, right? And this algorithm doesn't really take away that second step at all. It just creates a maybe more simpler, primitive way of generating those segments. I'm gonna take a lunch break now, and I don't like where I'm leaving this, because my original goal was to clean it up and open source it, and I should have done that. And I might actually still have a chance of going back to that, and maybe that's what I should do. Maybe I should, you know, call that get cell outline 2, right? Go back to the original algorithm, do what I did in terms of making it independent of cells and all that stuff, you know, add a little bit of of example code and then open source that. And then I can come back to this later if I want to create a second version. You know what I mean? Because I don't even remember what the like I did a few things. I mean, some basic stuff. Like I knew these shape arguments didn't need the cell inserted as a third element. So if I get rid of all of these, so if I get rid of get cell outline 2, does this not output what it should? Ah, yes, because I haven't changed it from object indexing to array indexing on the cell elements. So this should just be row R C. It's just R C C. R C. 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 And undefined 44. Look at that. There we go. I think that was the most significant stuff I did. And I think I made this into a one-liner. So if I do this, I think that works. I can get rid of this as well. Kind of superfluous. Shape.length. 0 shapes.push. Shapes.push. Follow shape. Yeah, because this can return multiple elements per whatchamacallit. Alright, so anything else obvious that we can just get rid of? This is applying the offsets. I'm trying to remember if I had already simplified this part. We're mapping the exits to entrances. So I think this is just the basic algorithm, like almost verbatim, which might be good as well. If people want to replicate it, make sure their code does the same thing as the selection cages, etc. Then this algorithm will do the trick. All right, so this would have to go together with some sample code. And maybe I can simplify this sample code here a little bit. For example, if I'm only gonna put in one of these here, I might as well just I was just thinking maybe I just put it in the HTML as part of the sample. I guess the easiest sample would be if the whole thing was a singular HTML file, perhaps. Right? And if we don't split these up into multiple functions, so get rid of any function we're not actually using, for, you know, functionality purposes. Get rid of that. Put that in here. Not sure if we need these. We definitely don't need these. We don't need this. Okay. And since we're calling this only once, pretty sure we don't need that either. path. 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 Type. Path. All right. Get rid of that. Get rid of that. Size 400. Get rid of any references to 400, I guess. So set up canvas. Set up SVG. And then down here we're doing all of that stuff. Okay. I guess we might as well put that in here, since we did it the same with the SVG. We also had it included there. No, but you know what I can do is I can do Z close path to make it a little bit more equivalent to the SVG drawing. Technically we don't need begin path, but I think I'll leave it here. Yeah, unfortunately the switch cannot be. I wish there was like a functional version of switch. Right, get rid of that, get rid of that. Guess we can turn this into an array of cell. Oh, does that make sense? Don't need that. I'll do the SVG after the canvas, since we actually started with a canvas. Canvas, draw SVG. And we'll do something like let cells in cage equal. My stomach is growling continuously now. Why am I so hungry? I'm tempted to pull this out, but if I leave it in here, the nice thing is I can move these. I can move. Wait, I can move these. No, first I'm getting rid of this. Then I can move these two in here. Like that. I'm tempted to change, if I change the units of the, no, with the canvas it doesn't work, because I was going to say, if I change them to be 1 pixel per cell. A map with callbacks, yeah, basically. not seeing the questions. I'm seeing them. Yeah, I might be just out of sync with questions on the chat. Sorry, because I just look up from time to time and then just answer what I see. All right. I don't know if this is worth putting into a separate function, but this should be relatively clear. Maybe I'll do this here. Personally, I like indenting behind a comment for a sort of you know, something that really should be a function. I don't know. Some people might not like that. Now, the question is what I'm going to do with this little dinghy. That shouldn't be in here, obviously. So let's take all of this, right? Do this, put that in there, and make sure we're highlighting this, syntax highlighting this correctly. Now let's get rid of this little horror. And let's see if we can save this under my open source repo. And I don't think I have created a path for this yet. Format, compression. I want to kind of create a folder for this sort of stuff, right? Drawing, I guess. Rendering. I'm just going to call it drawing for now. And then I'm going to call it cell out. Oh, no. Cage. Outline. We're going to make this an HTML file. And then all of this is actually going to live inside a script tag. Like this. And this whole thing is going to be an HTML file. The body. Right. And I should be able to just drag this whole thing into a browser. And it should just do its thing, right? Yeah. Wow, the colors look so different on a white background. And I think that should, you know... And maybe I should put in some little preambles and whatnot. I think there's like author meta tags and stuff like that, and I'm just going to stick those in there. Cage outline. And I think we're gonna point this to the GitHub repo. Like this. And I don't think... do I have a icon on Sven Codes at the moment? It's the SudokuPad icon. No, I don't actually want that on here. And I'm gonna make the background dark, so my eyes don't burn. Make it extra evil. All right. There we go. Oh, it's actually too light. Like that. Yes, yes, that's nice. Well, Most of the chat here seems to be from YT, from YouTube, sorry. I don't know, 20, 30 chat messages, mostly from Fryer. I don't know, I think a lot of that chatting happened earlier in the stream. So the last 20 minutes? No. Wait. Yeah, no, a lot of it happened early in the stream. Okay, I don't know. Doesn't really matter. All right, let's have a look at the repo. Yeah, where is it? I want to add something. This is from my CTC website. Yeah, for now this is fine. Actually, I'd like to put the version in, just in case later on I come back to it and... I think there's a meta name description content algorithm from ctc.crack app.crack.cryptic.com something like that, whatever. All right, so if I push this on here now, this should appear here and should be accessible. Now, I think there's a way of loading the raw. Oh, it won't load it as an HTML file though. Ah, that sucks. I'm guessing it's forced as a plain text type. GitHub raw serve HTML. Is there some way of serving this as HTML? It used to be possible. Is this really... Yeah. Yeah. I don't know if I want to rely on something like statically here, to be honest. Let's see. If it starts from here, right? So if I do this, does that do the thing? Ah, it's not so you have to actually register with it. All right, doesn't matter. It's probably a bad idea, anyways. Yeah, but I don't think. I think I have to set something else up for that, which I don't want to actually. Because I think I have to actually tell GitHub Pages that to do this to this thing. Yeah, no, I don't want to create a site, right? It's just this one file. The rest of it is not a GitHub page, so it won't work. All right, but you can all see the code from today's stream. Now, it doesn't have the version that I started working on halfway through and then changed my mind about. So, yeah. Maybe I'll get back to it. But to be honest, I need to get back to the editor. Like, I spent all week last week to improve the pen tool stuff. And that was supposed to be like half a day, not, you know, not a whole week. So I think feedback I've gotten is that it's actually worked. Oh man, I expect the line to appear sooner. But maybe it's good that it doesn't appear right away. And I think you can still potentially switch from one to the other without lifting your finger. But anyway, the pen tool should be much better on mobile now. But I need to launch the site to get it all test out for myself. This version, I think the current version in production is quite old. It's 0.141. It's like 20 versions out of date. So yeah, this week I really need to get that sorted. Anyway, in the meantime, thanks for hanging out. I hope I'll manage to do another stream later today, and you'll join me for that one, where we finally get back to working on the editor again. And just to get the week started, but then throughout, like this week is really when I need to get the release ready. I need to get version 161 or wherever we're at out the door, clean up the letter tool, last tasks to be done, and then off it goes. And then I can really dive into the editor and get that into some sort of early release stage as soon as possible, for my patrons especially. Speaking of Patreon, I just got a patron today. There were a few days without patrons. That always makes me sad. So the patron today, thank you so much for joining. It makes me happy very much so. It's over at patreon.com/SvenCodes. Same for YouTube subscribes. I'm hoping to get somewhere. I mean, it's, you know, you're watching me code for hours and hours and hours. So I know it's not the content for everybody, but the more subscribers there are, the more I'll be encouraged to do something more useful. And I'd like to start doing shorts about the sort of really not so hidden features of the app that a lot of people seem to forget, especially Simon. I'm mostly doing them for Simon to remind him to switch to this large digit mode off when he's playing killer Sudokus. But there's lots of other settings people don't know about. Flipping the keypad, you know, disabling background colors, little things like that. So I want to do at least a short on each of the settings for now, and then maybe a few other things like, hey, here's the bookmarklet to load in puzzles, or here's this thing, or if that link doesn't work, do this thing, you know, like little tips and tricks, and I'll see how it goes. And I think maybe that'll be useful to some people. Anyway, thank you very much. Thanks for joining. Always helps. Hope to see you later. Take care. Have a good day. Bye.